Today we are going to discuss the new one, that is solubility and Henry's law. So what is solubility? So what is solubility and what about Henry's law? So in previous class we discussed about concentration terms of solutions and some numericals on the concentration terms. Now, if you go to the new topic, that is solubility and Henry's law. So solubility, what is solubility? What is the definition of solubility? The amount of a solute dissolved in 100 grams of a solvent. See, the amount of solute dissolved in 100 grams of a solvent to form a saturated solution. To form a saturated solution. Saturated solution at a given temperature. It is called as solubility. So what is solubility? What is solubility means the amount of solute dissolved in 100 grams of a solvent. You know what is solute? What is solvent? You know very well. What is solute? What is solvent? Solute nothing but less quantity. Solvent nothing but large quantity. So some amount of a solute dissolved in 100 grams of a solvent to form a saturated solution. A saturated solution. It is called as solubility. Means how much amount of solute is dissolved in solvent. To that we are going to discuss how to find out the amount of solute dissolved in a solution. Okay, so that is the definition of solubility. Here we are writing saturated solution. So what is saturated solution and what is unsaturated solution? And third one, supersaturated solution. So first one, saturated. So before we define unsaturated solution. What is unsaturated solution? So unsaturated solution means, what is unsaturated solution means? A solution in which solute can be dissolved. In which more solute you can write. More solute can be dissolved. More solute can be dissolved. For example, if a solution is present in that vat solute, it may be sugar or salt. So what happens means it dissolved in that water. So we are adding the sugar and that sugar is dissolved in the water. Means it is an unsaturated solution. It is unsaturated solution. So more solute can be dissolved, then it is called as unsaturated solution. If the solution is dissolved in the solute, we are adding the salt nothing but solute, it is dissolved in that water. Another spoon is added, it is also dissolved in water. Means at that condition, that solution it is called as unsaturated solution. Clear? The second one, saturated solution. What is saturated solution means? No solute can be dissolved. No solute can be dissolved. That solution is called as saturated solution. Means certain limit it is present. So adding the sugar, it is dissolved in water. So number of spoons, if you add 10 spoons, 10 spoons are dissolved in that water. But 11th spoon is added, it is not dissolved in water. Why? What is the reason means? The situation is changed, the condition is changed. Unsaturated is converted into saturated solution. Clear? Unsaturated is converted into saturated solution. How it is possible? By dissolving salt or solute. So when solute is dissolved, before that the solution is called as unsaturated. After adding some quantity of solute, it is converted into saturated solution. Clear? Then what is supersaturated solution? What is supersaturated solution means? See, for example, after 10 spoons of sugar, the unsaturated solution, by adding 10 spoons of sugar in that solution it is converted into unsaturated to saturated. If more quantity of solute is added, more than required amount, it is called more than required solute. More than required solute is added, then it is called, that solution is called supersaturated solution. Supersaturated solution. Clear? Supersaturated solution. So that's about, means the salt which is dissolved in, which is added in saturated solution, it is not dissolved. You can see the salt or sugar. Clear? That solution is called as supersaturated solution. Clear? That's about types of solution. That's about types of solution. Clear? Types of solution. Then, if you go to the next one, if solubility depends on any factors. Any factors are present on solubility of solute. There so many factors are present. Now we are going to discuss those factors. Solubility depends on the solubility. Solubility depends on, the solubility depends on what? The first one, nature of solute, nature of solvent. First one, nature of a solute. Second one, nature of a solvent. And third one, temperature. And fourth one, pressure. Pressure. Okay. So these are the four factors which influence the solubility. See, if you go to the factors which influence the solubility, the first one, solubility of a solid in liquid. We are going to discuss two different types. The first one, solid in liquid, gas in liquid. So if you go to the first one, solubility of solid in liquid. The first one, solubility of a solid in liquid. Which factors? What are the factors will affect the solubility of solid in liquid? We discussed here the first factor, nature of solute and solvent. See. Nature of a solute and solvent. So nature of a solute and solvent, nothing but if the solvent is polar compound, polar and non-polar. You know very well. Polarity, nothing but positive and negative charges. So if polarity present, those are called as polar compounds. If the solute is polar compound, it is dissolved in polar solvents only. If the solute is non-polar compound, it is dissolved in non-polar solvents only. Clear? Polar compound. Polar compounds dissolved in polar solvents. Example, NaCl in water. Na is a polar because Na plus Cl minus ions are present. H2 also H plus and OH minus ions are present. So polar solvent dissolved in polar solute dissolved in polar solvent. Clear? Then non-polar compounds dissolved in non-polar solvents. Non-polar solvents. Example, benzene CCl4. Here benzene and CCl4 means CCl4 dissolved in benzene. It is a non-polar, so it is also dissolved in non-polar solvent. Here, that's about nature of solute and nature of solvent, which affect the solubility of a solute. If solute is a polar, then it is dissolved in polar solvents. If the solute is non-polar, it is dissolved in non-polar solvents. Clear? And for the second one, means a third one, temperature. Temperature. If you observe the chemical reactions, there are two kinds of reactions you can observe. First one, endothermic reaction. Exothermic reaction. Endothermic reaction. What is endothermic reaction? The reactions in which temperature or heat or energy is utilized, used, observed for the completion of the reaction. It is called endothermic reaction. Endothermic reaction. For example, here it is a piece of chalk is present. To break that one, we need some energy. Means by absorbing energy, it is converted into two pieces. Means energy is utilized to break the bonds. It is called endothermic reaction. Exothermic reaction, nothing but for a chemical reaction is completed, there is release of energy. So there is not absorption of energy. It is a release of energy. Energy is released. Energy is released. That reaction is called as exothermic reaction. Exothermic reaction. Clear? Exothermic reaction. So endothermic, nothing but energy is heat is released. Exothermic, nothing but heat is endothermic reaction, nothing but energy is absorbed. Exothermic reaction, nothing but energy is released. Endothermic delta H means change in enthalpy, change in energy is releasing nothing but delta H is equal to positive or negative? Negative. It is positive nothing but absorption. Here delta H is equal to negative. Delta H is equal to negative because energy is released. See, dissolution. What is dissolution? Dissolution nothing but formation of a solution. When a solute, it may be gas or liquid or solid, placed in, dissolved in solvent to form a solution. That process is called as dissolution process. So dissolution is endothermic. If it is endothermic, delta H is greater than 0. Delta H is greater than 0. So solubility increase by increasing temperature. If dissolution process is endothermic, that's why I am saying here definition of endothermic and exothermic. What is dissolution? Simply you can say formation of solution. So formation of a solution is endothermic. Formation of a solution is endothermic. Then what about its delta H? Delta H is a positive, always greater than 0. At that conditions, solubility increases when the temperature is increased. When temperature is increases means solubility also increases. When delta H is greater than 0. When if the dissolution process is endothermic reaction. Clear? It is the problems are present or questions are present. Clear? The second condition. If dissolution is exothermic, means formation of a solution is exothermic. Then what about its solubility? What about its delta H? Delta H is less than 0 because negative charge. Delta H is less than 0. Clear? Then solubility decreases if temperature increases. So in these conditions, temperature is increased, solubility decreased when delta H is less than 0. At that condition, dissolution process is exothermic reaction. Clear? That is the third factor which influences the solubility. Solid in liquid. Clear? Say the fourth one, pressure. What is the pressure effect on solubility? Solid in liquid, any effect? There is no effect. No significant effect on solubility of solid in liquid. Clear? So that's about solubility of a solid in liquid. We go for next one. Solubility of gas in liquid. Solubility of gas in liquid. The first one, nature of a solute. Nature of a solute. See, after concept, then only the questions are very easy. So without listening concept, it is difficult. Simply question answer like it is not good. So that's why I'm briefly explaining this topic. Nature of solute. If nature of solute means easily liquefiable gases are easily liquefiable gases are more soluble. Easily, clear, easily liquefiable gases are more soluble. So what about gases? Soluble in liquid or not? Soluble. But the first factor, nature of a solute. If the solute is easily liquefiable, what is liquefiable here? So liquefiable nothing but gaseous state to liquid state. By applying pressure, simply I am saying, see, vapors are present. In between vapor particles, the distance is more. With one particle and here two particles are present. Between this distance is more, so that those are present in gaseous state. If you increase the pressure, so what happened? They come close to each other like this. Means it is the first state. And if you go to this, by increasing the pressure, what happened? Decreases. So they come close together. They come close together means what happened? Distance decreases. So gaseous state is converted into liquid state. So that is liquefaction. If the gas is easily liquefied, then those gases are more soluble in liquid. Clear? Example, CO2 is more than O2 and of course H2. O2 and H2. See, if you observe the oxygen present in water, it is very less because human beings, we are not surviving in water because very less oxygen is present. So due to life gas, we are living. If you go to the water, the dissolved oxygen is very less. So that's why we can't survive in water. We can't live in water. Clear? When carbon dioxide, if you go to cool drinks, carbon dioxide gas is present. Soda. You know the Goli soda. So in soda, carbon dioxide gas is dissolved. Clear? More gas is present because it is easily liquefiable by applying pressure. So that is the first one, nature of a solute. Easily liquefiable gases are more soluble in liquid. Example, carbon dioxide more soluble than oxygen and H2. Clear? The second one, nature of solvent. Nature of a solvent. What is the nature of a solvent? The gas is capable of forming ions in aqueous solutions. The gas is capable of forming ions in aqueous solutions are more soluble. Clear? The gases which are capable of forming ions in aqueous solutions are more soluble. Clear? Example, HCl. H plus Cl minus is the easily informed charges, ions. So that is nature of solvent. Then if you go to the temperature, third one. Temperature increases, solubility decreases. Or you can write here, solubility is inversely proportional to temperature. Means if the temperature is increased, solubility is decreased. Best example, a cool drink bottle, a cool drink solution. When it is present in freeze, where the temperature is less, refrigerated. If you open the cap of the cool drink, what happens? The gas will come out. The same bottle, if you kept in a room, their temperature is more high. If you open the cap of the bottle, what happens? There is no gases are coming outside. Why? What is the reason? Means because temperature is more temperature. You can see the live example. You know that example. When the bottle is kept in a refrigerator, another bottle is kept in a room. What is the difference? Temperature is different. The bottle which is present in the refrigerator, if you open the cap of the bottle, the gas will come out. The same, the second bottle which is kept in the room, if you open the cap of the bottle, so what happened? The gases are not coming outside. So what is the reason? Means due to temperature. In refrigerator, temperature is less decreased. So that's why solubility increases. If the temperature is increased, solubility decreases. Clear? And the third one, fourth one, the last one. Pressure and solubility. If pressure is increased, solubility increases. Same example, cooling bottle. The cap is present at high pressure. The bottle is filled with cap. What happens? The gases are present in water, dissolving water. More gases are dissolving water. Clear? So that's about solubility and the factors which affect the solubility of solid in liquid, gas in liquid. Clear? Explain the solubility of a gas in liquid. In 1803, Henry proposed one law. Clear? So what is that law means? Henry's law. So what is Henry's law? Says that the solubility of a gas in liquid in liquid is directly proportional to the partial pressure of the gas. Present above the surface of liquid or solution. Above the surface of liquid or solution. It is called as Henry's law. What is Henry's law? The solubility of a gas. How much amount of gas is soluble in liquid? It is directly proportional to partial pressure on the gas present above the surface of the liquid solution. Clear? See, if you go to the here, for example, here it is a liquid and it is a gas. Volume it is. means there is no pressure. Clear? It is a gas and it is valuable. See, if you increase the pressure, so what happens? Pressure is increased on the solution. So the solubility of a gas in a liquid is directly proportional to the partial pressure gas present on the surface of the solution or sample. See, it is a surface. If you increase the temperature, nothing but here solubility increases. Here, of course, it is present, but the value is present. Here, it is a value. It is a gas and liquid. So solubility increases. Solubility increases. If you increase the pressure, it is called Henry's law. I think you understood. Clear? It is a pressure piston. If increasing the pressure of the solution, what happens means gas also soluble, more soluble in liquid. Clear? So that's about Henry's law. So according to Henry's law, partial pressure or you can say solubility of a gas is directly proportional to partial pressure. So solubility is directly proportional to partial pressure. So solubility of a gas, nothing but mole fraction. Mole fraction, it is also used to represent the solubility. So partial pressure is directly proportional to mole fraction of gas present in the solution or solvent. Clear? So if write in symbolic way, partial pressure is directly proportional to mole fraction of gas. If you remove this proportionality, you have to write one constant. So P is equal to KH to mole fraction of gas. So it is called as Henry's equation. Henry's equation. Henry's equation. Clear? Henry's equation. So that is Henry's law. Henry's law. Clear? The solubility of a gas in liquid is directly proportional to the partial pressure of the gas present above the surface of a solution or liquid. So it is Henry's law. So partial pressure is directly proportional to mole fraction. So mole fraction is representation. It will represent the solubility of a gas. So directly proportionality. If you remove this proportionality, KH we are right. KH is the Henry constant. Here some questions are important. Okay. KH depends on nature of the solute and solvent. KH, Henry's constant. KH value depends on nature of the solute and nature of solvent. Then the KH value is high. KH is value is high, increases. Solubility decreases. These are the very, very important. The KH increases, solubility decreases. Temperature increases. KH increases. KH increases, but solubility decreases. Solubility decreases. Clear? That is about Henry's law. It is very, very important for IP and competitive exams also. Clear?